Welcome to the next lesson in this chapter, where I'm going to show you how to implement token-based authentication in ASP.NET Core. Probably the most popular type of token used for authentication purposes is a so-called JSON Web Token. I like to pronounce it as JWT, but you will also hear this weird name out there called JWT for JSON Web Token. Now, what are JSON Web Tokens? They are a stateless authentication approach, which means that the resource server, in our case this will be the Evently backend application, does not have to store any state for the user's session. All the relevant information to authenticate and possibly authorize the user is contained inside of the JSON Web Token. It's also very easy to integrate into ASP.NET Core because we have some excellent abstractions in place. Now, I want to spend a moment to discuss what the authentication flow will actually look like when we implement it into our system. And in the previous lesson, we introduced another component into our system that will handle user authentication, and this is the Keycloak identity provider. So where does Keycloak fit when it comes to authenticating the user with the Evently API? Here's the flow that we are going to implement. The user will authenticate with Keycloak by sending their respective username and password, and Keycloak will respond with an access token, ID token, and refresh token. Then the user is going to send an API request to our API and include the access token. On the backend, we are going to take this access token and evaluate if it is a valid access token or not. For some of the details on the JSON Web Token, we are going to reach out to Keycloak to obtain the OAuth metadata, which is going to contain some useful information, for example, validating the signature on the JSON Web Token. And if the token is valid, we are going to return an API response to the user. So let me show you how we are going to implement this authentication flow into our system. We can think of authentication as another cross-cutting concern in our system, so I'm going to implement it in the common section of the Evently application. And I'm going to introduce the required code as part of the Evently Common Infrastructure project. Let's go ahead and add a new folder inside that I will call authentication. Inside of this folder, I'm going to encapsulate everything that's required to configure authentication using JSON Web Tokens. So let's start with a new class that I will call authentication extensions. I'm going to make this an internal and static class, and I will add another method inside that's going to be also internal and static, returning an iService collection interface, and I'm going to call it add authentication internal. This is actually going to be another extension method on the iService collection interface. And here we're going to configure the required services for authentication. The next thing we need is a NuGet package that's going to help us implement JSON Web Token authentication. So let's look for JWT Bearer, and we are going to install the latest version of Microsoft ASP.NET Core Authentication JWT Bearer. With this NuGet package installed, let's go back to our authentication extensions and we are going to configure some services. So I'm going to add authorization because these services will be needed to also implement authentication. And then I'm going to say services add authentication, as you might expect. And then we're going to say add JWT Bearer. I'm also going to enable an HTTP context accessor because this will be useful later, but I will be using it to fetch the current user's details from within our modules, but more on that later. Now back to our JSON Web Token configuration. The usual setup that you will see is passing in a delegate to configure the JWT Bearer options. If we take a look what we can set on this object, it will be things to validate the JSON Web Token, such as the audience, the authority. You can also access the token validation parameters, which has some other properties, for example, the valid issuer or the issuer signing key. However, my preferred approach is to not configure anything inside of this delegate, but I prefer to configure authentication using application settings. So we're going to remove all of this, and this method will remain simple like this. Of course, we can't forget to call it, and I will call it from the add infrastructure method. And in fact, let's add this call to the top of this method. So I will call add authentication internal so that we don't have to think about this later. And whenever this method is called, which is from the program file when we are configuring the application startup, we are also going to add the required authentication services. So if I'm not going to configure the JWT Bearer options by providing a delegate here, how am I going to do it? I'm going to provide another type inside of the authentication folder. this is going to be a class called JWT Bearer Configure Options. And the reason is that the JWT Bearer Options type is an iOptions implementation, and we can implement the iConfigure named options and specify the JWT Bearer Options type. When we implement this interface, you will see that it has two methods, a configure method and a configure method accepting a name. And what I can do from this class is set up the JWT Bearer Options using my application settings. So I'm going to inject an iConfiguration instance, and this is the awesome part about using configure options, is that it supports dependency injection. So with iConfiguration injected, I'm going to add a constant to represent my section name. So let's call this the configuration section name. And the name that I'm going to assign it is authentication. And then in the configure method that doesn't accept a name argument, I'm going to say configuration get section, and we can pass in our constant, and then I can call bind and pass in the options instance. And this will bind the values in my application settings to the properties with the same names on the JWT Bearer Options type. In the other configure method, let's just call the one that doesn't accept a name and pass in the options instance, and it's also going to be configured from application settings. Now we also need to configure this type with our application services, and we're going to do that from the authentication extensions class. We will say services configure options and specify JWT Bearer Configure Options as the generic argument. What is the next thing we need to do? I will head over to the program file, and here we need to include a couple of middleware. I'm going to add these middleware after the call to use exception handler, and let's start with app use authentication to add the authentication middleware, and then let's introduce the authorization middleware. The order in which you specify these middleware is important, so keep that in mind when implementing this. It should be authentication followed by authorization middleware. Now would also be a good time to introduce the relevant section in our application settings, and I'm going to add these values right above the Serilog setup. And in order to save us some time, I'm going to paste in the configuration sections. Of course, you can copy this from under this video and include it in your application settings. And let me walk you through what we have here. So I defined two sections, the authentication section that I'm referencing from my JWT Bearer Configure Options type, as well as the Keycloak section that we're going to cover a bit later. For now, let's focus on the authentication section. Here, I'm configuring the audience for our JSON Web Token authentication, as well as the token validation parameters, or to be more precise, the valid issuers array. I'm also configuring the metadata address and the require HTTPS metadata property by setting it to false. I'm also going to provide a relevant value for my application settings development JSON file, so let me include that. And of course, you can find this exact value in a code snippet under this video. Now let's examine what are the actual values that we will be setting in the development environment. So we are setting the audience to account. And if you recall from the previous lesson, when we were examining the JSON Web Token obtained using the public client, or to be more precise, the access token, it had an audience of account. So this is the value that I'm setting here so that it will be validated against that JSON Web Token. Now, the more important things are the valid issuers, and the reason I'm using an array is so that we can provide an internal valid issuer as well as an external valid issuer. Let me explain what I mean by this. So you will notice that the route here points to our Evently identity service, which is the name given to our Keycloak container in our Docker Compose setup. Then this is the internal port of Keycloak, and then our custom realm called Evently. However, since I'm going to be obtaining the access tokens by calling Keycloak directly, I also need to set up another valid issuer which points to localhost. So with this configuration, I'm handling both getting an access token directly from Keycloak on localhost and also getting an access token internally inside of the Docker network. I'm also setting the metadata address URI, which is pointing to the base address of the Evently realm, and then it's using the standard route of well-known OpenID configuration. This will contain the required metadata to validate the JSON Web Token and, among other things, confirm that the signature of the JSON Web Token is valid. In the Keycloak section, I'm just setting the URI that's going to point to the Keycloak health check endpoint internally in the Docker network so that we can introduce this as another custom health check. But we will deal with this later after setting up authentication. So now we are ready to give our authentication setup to try, because this is all there is to the required configuration. And I will head over to the Get Categories endpoint, and let's add a requirement that the user has to be authorized when accessing this endpoint. We can achieve this with minimal APIs by calling require authorization, and this is similar to adding the authorize attribute inside of controllers. This method also supports introducing policies as an additional argument, which we are going to use later when introducing permission-based access control, but for example, you could specify your custom permission as an argument to this method. So with the require authorization call in place, let's start our API and check if authentication is working correctly. I'm going to send a GET request from Postman to the Get Categories endpoint in our API. So if I hit send, you can see that we get back a 401 unauthorized response, which means the user is not authenticated to access this endpoint. Let's see if providing an access token is going to solve this. So I'm going to head over to the access token endpoint, and remember that we still didn't implement user registration with Keycloak. So this is the user that I created manually inside of the Keycloak administration dashboard. So I'm going to hit send, and using the public client, we can obtain an access token for our Keycloak realm. Now if I go back to the Get Categories endpoint, and inside of authorization, I set it to be bearer token, and I'm going to add the bearer token value. So if I hit send this time, you can see that we will get back a response because now we are providing a valid JSON Web Token and we are successfully authenticating with our API. Behind the scenes, I'm going to update all of our endpoints to now require authorization, except the registered user endpoint that's going to allow anonymous access. And I'm bringing this up because you can either do it on your own or you can grab the updated source code at the start of the next lesson. Now, the next thing I want to do is to integrate our Keycloak health check into the existing health checks that we have in place. So we can do that fairly easily from the add health checks call, and we need a way to call a specific health check based on a URI. So I'm going to add another NuGet package. Let's look for health checks, and I'm going to install ASP.NET Core health checks URIs, and let's add the latest version. With this NuGet package installed, we can go back to the program file, and I can say add URL group, and we need to pass in a few arguments here. The first one should be a URI pointing to a resource exposing the health check endpoint. So I'm going to say builder configuration get value, which is going to be a string, and the actual value will be at Keycloak and then health URL, which is the value that we set in place in our app settings development JSON. We also need to provide what is the HTTP method that should be used to call this health check. I'm going to say HTTP method get. Then we can provide a name for our health check. So I'm going to give it the name of Keycloak. Another thing that's complaining is that the getValue method could return an empty or null string. So I'm going to use a null forgiving operator, but in reality, you want to put in place a more robust check to make sure that the value returned from your application settings is actually present. Now let's start the application and see if our custom health check for Keycloak is working. I'm going to send a GET request to the health endpoint on our API, and if I hit send, we will get back a 200 OK response, meaning that the status of our API is healthy. You can also see that we have an additional health check that I didn't show you so far, which includes the mass transit in memory bus, which is also healthy, but what we are interested in is the Keycloak health check, which we configured right now, and you can see that the status of this health check is healthy because Keycloak is running. If I were to temporarily turn off the Keycloak container by stopping the container manually and then sending another request to the health endpoint, you can see that the Keycloak health check is unhealthy because we are unable to connect to the container internally. And of course, if I restart the container and it is up and running and I send another health check request, we should get back a healthy response after a given period of time. So you can see that the first request failed because Keycloak wasn't up and running yet, but right now it's running and we get back a healthy response. I think we can wrap up this lesson about setting up token-based authentication in ASP.NET Core. We successfully implemented authentication using JSON Web Tokens that we obtained from Keycloak. As a small bonus, we also introduced a health check that's going to verify the status of our Keycloak instance. In the next lesson, we are going to implement user registration with Keycloak.